Hello and welcome back to Math 1500 Applied Business Mathematics, Connecticut State Community College. This is section 8.1, the sample space and events. We're going to look at a sample space, experiment, outcome, event. Again, this is a lot of vocabulary. I feel like in this chapter, in this unit, we are talking a lot of vocabulary. So first of all, some definitions here. An experiment. It's an occurrence with a result. So for example, I roll a die. The event is rolling the die. If I flip a coin, the event is flipping a coin. I select a student, the event is selecting a student. It's some thing I do where there's a result. That result is called an outcome. If I flip a coin, I might get heads, I might get tails. If I roll a die, I might get a 1, 2, 3, 4, 5, or 6. Okay? The set of all of those possible outcomes is called the sample space. Formal definition for list of, or formal term for list of possible outcomes. So here's just as an example, I did an experiment. I flip a coin and I observe the side that faces up. If I flip a coin, the outcomes are either heads or tails. H is for heads, T is for tails, obviously. I flip a coin, the outcomes are heads or tails. So my sample space, S, we use S for the sample space, is the set of outcomes, heads or tails. It's that simple. So here's an example that actually comes from our textbook, so all credit to them. In a survey conducted by the Bureau of Labor Statistics, the high school graduating class of 2010 was divided into those who went to college and those who did not. Those who went to college were further divided into those who went to two-year colleges and those who went to four-year colleges. All graduates were also asked whether they were working or not. Find the sample, I'm missing an N there, find the sample space for the experiment. Select a member of the high school graduation class of 2010. Classify his or her subsequent school and work activity. So if I randomly select a student, the student might be going to college, the student might not be going to college. And now we're not going to say college and then 2-year, 4-year. So what we're going to say is that I'm going to select a student and the student's either going to college, a 2-year college, not going to college, they're going to a 2-year college or a 4-year college. If the student is going to a 2-year college, they're either working or not working. 4-year college, they're working or not working. No college, they're working or not working. So there's actually 6 different possible outcomes here. I could select a student going to a 2-year college who's working, 2-year college not working, 4-year college working, 4-year college not working, no college working, no college not working. And then notice down at the bottom here, we have the sample space. The outcomes are 2-year college and working, 2-year college not working, 4-year college and working, 4-year college and not working, no college working, no college and not working. Simply a list of the possible outcomes. It's all that a sample space is. Okay. Complement, union, and intersection. We've seen the word complement before. Okay, the complement of an event, E, is the set of outcomes that are not in E. So if E is events that occur, then the complement of E would be the events that do not occur. So for example, you take 4 shots at the goal during a soccer game and you record the number of times that you score. Now my sample space would be the number of times I score. I'm going to fix that brace. The number of times I score could be 0, 1, 2, 3, or 4. E is the event that I score at least twice. So E would be I scored twice, or 3 times, or 4 times. E complement would be the event that I did not score 2 or more times, which means I scored fewer than 2 times. That would be 0 or once. Again, fairly simple. Union, we've talked about union and intersection in the past. The union is a set of all outcomes that are in E or F or both. And again, we have that E union F symbol. So let's look at an example. I roll a die. E, the outcome is a 5. So E would be that the outcome is a 5. I did not list here the universal set. The universal set S would be the set 1, 2, 3, 4, 5, or 6, because if I roll a die, those are my possible outcomes. E is the outcome the outcome is a 5. So the set is 5, but I don't need the comma here. Let me fix that 5. F, the outcome is an even number, so F would be 2, 4, or 6. E union F would be the number is a 5 or an even number. So the union would be 5, 2, 4, 6. And I suppose I could have listed those in order, 2, 4, 5, 6. It doesn't really matter the order in which I list them. The union would be all of the elements that are either in E or in F. The intersection, again, hopefully you remember this from a previous video. The intersection is the set of all outcomes that are in both E and F. And again, we have our symbol here, E intersect F. Those are all the events that are in both, represents the event that both E and F occur. Again, I'm going to roll a die. This time, E, the outcome is a prime number. Now this gets a little tricky because 1 is not prime, 2 is. So 2, 3, and 5 are prime numbers. F, the outcome is even. The even numbers are 2, 4, and 6. Now E intersect F, that would be the number is prime and even. The only number that's both prime and even, the only number in both sets is the 2. So the 2 would be the intersection of those two sets. Very quickly, a quick definition. Mutually exclusive events are events that cannot happen simultaneously. If I pick a card, what's the probability that my card is a king and a black card? Those can happen together. There are 2 black kings in a deck of cards. If I pick one card from a deck, what's the probability that the one card I pick is both a king and an ace? That's not possible. Those outcomes, king and ace, would be mutually exclusive because one outcome excludes the other. Okay? So, for example, notice if I roll a die in E, the outcome is that E is an odd number, or the outcome is an odd number. So my set of E would be 1, 3, 5. F, the outcome is even. That would be the numbers 2, 4, 6. Notice, if I roll the die and get an odd number, it can't be even. If I roll the die and get an even number, it can't be odd. Those outcomes, even and odd, are mutually exclusive. The intersection would be the list of numbers that are both odd and even. So the intersection of E and F would be empty. And again, as in our previous video, we could either list the empty set with a set with nothing in it, or we could use the empty set notation. We can't use both. It's one or the other. I have a table here. Authors. Again, credit to the textbook where this comes from, but we have some new authors, established authors. They sent a book. It's going to be successful or unsuccessful. Okay? So consider the following events. S, the event S is that an author is successful. U is the author is unsuccessful. And new author in E, the author is established. Okay? Now S union, that's not sun. That would be S union N. That'd be successful authors and new authors. Now I'd be tempted to say that there are 30 successful authors and there are 20, so there are 30 successful authors and 20 new authors. However, and we saw this in a previous video as well, that I just included those 5 authors twice. The 5 authors that are both new and successful, so I need to subtract out that 5 so I don't accidentally include them. Okay, so that would be 45. Now notice if I draw the line here, vertical line for the new authors, horizontal line for the successful authors, the union would be everybody that's in that has a line once or twice. Okay. I'm going to change colors. S intersect N. Same thing, new authors, successful authors, but this time notice that those 5 authors are the only ones who are both new and successful. Okay, so what percentage of authors are are unsuccessful and new? Let me erase my lines up here. What percentage of authors are unsuccessful and new? And new. 15. Okay. 15 authors are unsuccessful. 70 authors are unsuccessful, 20 authors are new. However, it's only these 15 that are both new and unsuccessful. So that would be 15 of the 100 authors are both new and unsuccessful. So that would be 15%. Let me switch back to my blue for or. What percentage of authors are unsuccessful or established? So unsuccessful, established. Now we want or. So that's going to be all 80 of the established authors plus 15 more unsuccessful authors who are new. So that would be 95 out of 100 or 95%. Okay? So quick look at sample space and events. Hope this makes sense. And as always, if this is helpful, please remember to like or subscribe, and I will see you back for our next video. Thank you.